everyone, it's Mrs. Trombley. It's time for lesson 7-4, special products of polynomials. So we've already learned how to multiply polynomials, and now there are some special cases that if you see the pattern, it will make things go a lot faster for you, and I'm sure you love that idea. I know I do. I like when things take less time than necessary. So that's what we're looking at today. So basically we're going to do what we did before and then examine it for patterns, look at some rules, and apply it. That's the gist of it. So, some pairs of binomials show patterns when they're multiplied. You can use these patterns to multiply other similar pairs of binomials. I give you 3 sets right here to multiply through, and we're going to do these the regular way to look for the pattern, and then we'll talk about what's in that box below. So, if you were to go ahead and distribute this, and factor this, well, you're not factoring this, do the opposite of that. Distribute this. You would multiply the first, so x times x is x squared, and then the outside, we'd get negative 7x, and the inside, and the last. We would combine our like terms, and we'd end up with x squared, and when you have negative 7x plus a positive 7x, those go away, and we just get a negative 49, so I'm going to write minus 49, because that's the same thing as adding a negative 49. All right, let's do this again. This time the subtraction's first and the addition second. Okay, so 2x times 2x, that's 4x squared. And then outside 2x times 1 is 2x. Inside negative 1 times 2x is negative 2x. And last, a negative 1 times a positive 1 is a negative 1. We go ahead, combine like terms. 2x, negative 2x cancel out. I'm left with 4x squared. And then plus negative 1 is the same as minus 1. And last but not least, maybe you're already seeing the pattern. You're like, come on, just humor me. We'll add the opposite. 6g multiplied by 6g is 36g squared. 6g times negative 5 is negative 30g. 5 times 6g is a positive 30g. And 5 times negative 5, yep, that's negative 25. Combine our like terms, and we end up with 36g squared minus 25, or plus negative 5. That means the same exact thing. So as far as patterns are concerned, if you look at the polynomials that were given, I'm hoping you notice that basically the digits were the same in each pair, but the signs were opposite. We had one that was addition and one that was subtraction with the same digits in there. Here, subtraction, addition, but same digits, subtraction, addition, same digits. When that happens, the middle terms, they always end up canceling out because you always end up adding the opposite for both of them. And we end up with subtraction because when you multiply those outside numbers, it's always going to end up being a positive times a negative, which is a negative. So this little box, what this means, the sum difference pattern, if I have a plus b multiplied by a minus b, meaning the digits a and a match and the digits b and b match, but it's one's addition, one's subtraction, the result is always going to be whatever a squared is minus whatever b squared is. So if we put numbers with that, if you have x plus 3, x minus 3, so digits are the same, signs are opposite, the result is going to be x squared minus the 3 squared, which is x squared minus 9. So now, knowing that, instead of us multiplying all this out, when you look at a problem like this and you see, hey, those digits are the same, but the signs are opposite, this means it's just a squared minus b squared, or in this case, the a is p. So p squared, and I know it's supposed to be subtraction, that's the pattern, and then the b's in this case are 3, so b squared, 3 squared, is 9. And you'd be done. Take a look. Next one, same scenario, same digits for a and b, one's addition, one's subtraction. 3x squared, remember 3 squared is 9, x squared is x squared. And I know it's going to be subtraction, or if you wanted to write plus negative, you could. But 4 squared is 16, and then we're done. So when you see those patterns, it'll make it go faster for you. Now, if you forgot the pattern, of course you can do it the old way, and you'll be fine. It'll just take you a little bit longer to get there. Okay, we're going to look at another set of patterns happening here. I'm sure you like I like the patterns. I like when things go faster. So this is a little bit different. This, it's x plus 2, the quantity of x plus 2 squared. Now, a common mistake that I get is that people will say x squared plus 2 squared. That actually will not work. I can show you. Let's see. I'll throw it on the back of a paper here. Let's say that I had, you don't have to write this, but let's say I have 2 plus 3 squared, right? Now, you know order of operation says you would go ahead and you'd say, well, 2 plus 3 is 5, and 5 squared equals 25, right? Well, if you took 2 squared plus 3 squared, you'd end up getting 4 plus 9. 4 plus 9 does not equal 25. So when you see the squared outside of an addition problem or a subtraction problem on the inside, it doesn't mean you can just square that. What this actually means is that you have 2 plus 3 times 2 plus the quantity of 2 plus 3. That's what 2 plus 3 squared means. And think about this. That would be 5, that would be 5, and 5 times 5 is 25. So you can't just square each digit in there. It means that you have this quantity twice. So I think a great start to doing something like this would be to rewrite this as that. Meaning that x plus 2, quantity of x plus 2 squared, means x plus 2 times x plus 2. So again, you can't just take the x squared plus the 2 squared. It doesn't work, and you've kind of seen why with regular numbers. So let's go ahead and solve this out, and we'll look for some patterns in a minute. Okay, so I have, it's not the same pattern as the other, right? Because those are both addition, and then the other, with that pattern, one was addition and one was subtraction. So the first numbers in the FOIL, outside would be x times 2, inside would be 2 times x, and last would be 2 times 2. We combine our like terms, so this would be x squared plus 4x plus 4. Let's try another addition one. Remember, this doesn't just mean take 3y squared and then take 4y squared. This means that you have the quantity of 3y plus 4 twice. So FOIL it. First, 3y times 3y, 9y squared. Outside, 3y times 4 is 12y. Inside, 4 times 3y is 12y. And 4 times 4 is 16. So again, we end up with the same terms on the inside. So we get 9y squared plus 24y plus 16. So in both of these, they were addition. It was an addition of a binomial, and we squared it. And we didn't end up canceling out any terms, but every single time, didn't we end up with 2 of the middle term? Yes. Okay, I want to do these subtraction ones before we come up with our pattern. So again, when you see 2x minus 1 squared, that means that you have the quantity of 2x minus 1 twice. So now when you FOIL this, and yes, you can go ahead and you can do the key change. 2x times 2x, that's 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x. And a negative 1 multiplied by another negative 1 is a positive 1. Combine our like terms, and this time I get negative 2x plus negative 2x, that's negative 4x, right? So you can either write minus 4x, or you could write plus negative 4x. It means the same exact thing. Sorry. And we still have that plus 1. Last one more subtraction one to look at. Remember to rewrite this. Please don't just take the 2x and square it and the negative 5 and square it. Can you tell that people do that a lot? That's when I say things a lot. I don't want you to make those common errors. So we'll do this the long way to start. I will go ahead and keep change. If you're not a keep change changer, it's okay. Use your subtraction sign. It's fine. 2x times 2x, that's 4x squared. Outside, 2x times negative 5, that's negative 10x. And then we have negative 5 times 2x, that's negative 10x again. And a negative 5 times a negative 5 is a positive 25. When we combine these ones, you get 4x squared. Negative 10x plus negative 10x would be negative 20x. So you can either write minus 20x plus your 25, or you could write plus negative 20x plus 25. And let me circle it. I circled all the other ones. I can't leave that one uncircled. So in examining this, basically, you have a binomial that's being squared, right? And I showed you subtraction, I showed you their addition, so there's 2 addition ones, 2 subtraction ones. And when you're looking at the outcome with this, to get the first and the last terms, it's kind of like before. you just take whatever the a, if we look at this as a plus b, you take whatever the a squared is, and that's your first term, and you take whatever b is squared, and that's your last term, right? It works here, x squared and 4. It works here, 3y squared, the quantity of 3y squared is 9y squared, and 4 squared is 16. The quantity of 2x squared, or I'm sorry, the quantity of 2x squared, sorry, is 4x squared, and when I take 1 squared, it's 1. And the quantity of 2x squared again, it's 4x squared, and 5 squared is 25. Yes, so voila. And really it's the quantity of -5 squared, right? Because if we keep change that, this -5 is inside the parentheses, and remember, when you take a negative, the quantity of a negative squared, it means negative times another negative. That's why we end up with a positive. How do we get the middle term? So here I have a 4x. Here I have 24y. Here I have -4x, and here I have -20x. What's actually happening here is, when we do this step, notice that you have 2 of the same thing in the middle, right? Because we're taking x times 2 and 2 times x, which are those numbers right here. Here we have a 12y and another 12y, right? 3y times 4 is 12y. And then we end up taking 4 times 3y, which is another 12y. So all you're really doing to get this little middle term here is you are taking a times b times 2, because you end up with 2 of them. Again, I'll show you, like, this is like a times b, and then you're doing another b times a. It's happening twice. So all you have to do to figure out this middle term, and I'll write one of these out. Let's get a different color here. How about purple? Sounds good. Okay. To get this forward, what I'm saying is, you take 2 times whatever a is times whatever b is. Isn't 2 times x times 2 4x? Yes. To get this 24, take 2 times a times b. 2 times 3y is 6y. 6y times 4 is 24y. Over here, if we did change that, I would have 2 times a times b. 2 times 2x is 4x. 4x times -1 is -4x. And the last one, if you take 2 times 2x times, and that would be a -5. 2 times 2x is 4x times -5 is -20x. So basically, this little box down here sums up what this rule is, or the pattern is. If you are squaring a binomial, if it's addition, right, or if it's subtraction, it doesn't end up really mattering. You take whatever the first term is, and square it. So take a and square it, that's your first term. Take b and square it, that's your last term. And to get the middle term, you take 2 times the a times the b. So if you saw a problem like this, the quantity of x plus 3 squared, it's a square. That means you would take a squared to get your first term, b squared to get your last term, and to get the middle term, you would take 2 times a times b. 2 times x is 2x times 3 is 6x. If it's subtraction, you can look at this as the exact same thing. You're not really doing anything different. If I squared this first term, I'd get x squared. If I square a -3, and it's inside these parentheses, so it's the quantity of -3 squared, that's a +9. And when you take 2 times x times -3, 2 times x is 2, times -3 is -6, right? That's why this is subtraction. If you wrote it like that, it would be okay. So when you see you have a binomial raised to a power, all you have to do is write your first term as the a squared and your last term as the b squared. To find the middle term, you take 2 times a times b. So let's try a couple. There's only 4 little examples, and like we said before, these are going to go faster because we have this pattern now. We don't have to rewrite everything. So when you see a problem that looks like this, zoom in a little bit, hopefully we can see okay. You have to notice, oh yeah, this is one of those squared ones. This is one I can use a pattern for. So I have w plus 2 squared. I know that when I have a square, my first term is the a squared, so that would be w squared. know my last term is the b squared, so 2 squared is 4. To find this middle term right here, I take 2 times a times b. So 2 times w is 2w times 2 is 4w. That's it. If you want to, you can pause me and try to do the rest of these. Welcome back. Let's see if you're right. The first term would be the quantity of 5z squared, which would be 25z squared. My middle term is going to be 2 times 5z times 4. So 2 times 5z is 10z, and 10z times 4, yep, it would be 40z. And my last term would be b squared. 4 squared is 16. So if you have 25z squared plus 40z plus 16, you are correct. All right, the last two are subtraction, but we can do these the same exact way and just look at them as they are addition. So I'm going to go ahead and keep change them. If you have the rule without keep changing, I'm not going to force you to do that. You don't have to. All right, so first term would be the 3y squared. So that means 9y squared. My middle term would be 2 times a times b. So when you take 2 times 3y, that's 6y. And 6y times negative 1 is negative 6y. And then when I take the quantity of negative 1 squared, that's a positive 1. If you wrote this like this, even better, but either one is correct. All right, last but not least, to get the first term, I take the quantity of 4z squared. That's 16z squared. To get my middle term, I take 2 times 4z times negative 6, 2 times 4z, that would be 8z, and 8z times negative 6, 8 times 6 is 48, so it would be negative 48z, and the quantity of negative 6 squared would be a positive 36. And again, the best way to write it would be this way, but either way is fine. I'll see you tomorrow. You're all done.